Okay, so this is a number 4 problem, conversion between pressure-based equilibrium constant and the concentration-based equilibrium constant. So the Kp is a pressure-based equilibrium constant, and the pressure here is in the unit of atmospheric pressure, and Kc is a concentration-based equilibrium constant, and the concentration here in the unit of molar, which is mole per liter. And the equation that is we are going to use is Kp is Kc times RT to the power of delta n, and which is delta n is delta n for the gas phase only. Okay, so this is just for the gas phase. And so let's have a look at here. You have 1 moles of gas, 2 moles of gas, and producing, here it says a gas, so it will be 1 moles of gas. Okay, so what's my delta n here? Which is delta n gas is 1 minus 3. So that will be minus 2. Okay, so the minus 2 is the value here, and it was given that this is a 1. So the Kp value is given 6.3 10 to the minus 3, and the temperature is given as 225 degrees C. First thing that immediately what you need to do is 225 plus 273, which is to make it this value to be Kelvin. So that is 498 Kelvin. And the other one is R. And you might remember that you have two choices, 0.0821 or 8.314. You remember that? Joule per mole Kelvin. Both are in the unit of ATM, liter per mole Kelvin. These are all energy per mole Kelvin basis. And what is a number that I have to choose here? The answer is this one, and not this. Okay, and why am I choosing the one over there? Because if you look at the concentration base, they are using the unit of ATM, and the concentration base, they are using the volume here. So naturally, ATM, the volume per mole, is kind of put it in here. So therefore, the number that you must choose is a 0.0821. So having said them all, it's going to be a simple task now. So Kp, which is a 6.3 10 to the minus 3, that's a Kp value. And the Kc value, which is what I want to know, is 0.0821, and temperature 498 Kelvin, and to the power of minus 2. Right? So therefore, Kc is actually 6.3 10 to the minus 3 multiplied by 0.0821 498 to the actually plus 2 power. And then because this one has 2 significant figures and 3 significant figures, this one is now I can just carry 2 significant figures, which is 11. Okay, so the key information is because of the Kc to Kp conversion, when there is a gas reaction with a gas phase reaction is involved, because of the choice of the pressure and the concentration, the choice of the R is 0.0821. That's the That's a key message here. And then, of course, this has to be the equation. This one is in your reference sheet, so you don't have to remember this equation for the exam.